The bone can grow in two different ways. There's endochondral and then there's intramembranous. Endochondral bone formation is formed on an existing cartilage template. So there's a cartilage phase that's involved. In intramembranous bone formation, the bone is formed directly without the cartilaginous step. So intramembranous bone formation, as seen in these slides, you can see that there is remnants of cartilage still present in these tuberculi, and you can see the new bone that's forming in this darker staining here. And similarly on the right hand side, you can see the cartilage that's being replaced by the new bone. As opposed to endochondral, the intramembranous bone, there is no cartilage. The bone is forming directly. In this case, a developing bone here, as we've seen before in this picture, you can see the osteoblast forming the bone directly. So how does bone form during development? So in these cascading pictures, you can see the starting off very early on, labeled 1. You can see this here. There's the blue color represents cartilage. So it starts off as an endochondral bone formation, and then leads to a collar of bone forming. Then eventually there is a invasion of blood vessels into the cartilaginous portion, and that resorbs that area and starts to form bone in this area here. So this invasion of blood vessels is referred to as the primary center of ossification, and that eventually the ends of the bones, which are here, get invaded by the blood vessels as well, and they are referred to as the secondary center of ossification. So one thing you notice here is that there is some degree of cartilage that's left in between the primary and the secondary centers of ossification, and this region is referred to as the growth plate, and that's where the longitudinal growth of the bone takes place, and we'll look at that a little bit later. So here you also notice that as bone grows, the growth plate disappears, or in human it's referred to as fused. So that's when there's a stoppage in the longitudinal growth, and the individual stops growing. So just look at the growth plate in a little bit more detail. In this histological view, you can see the articulating surface here, and then you see the secondary center of ossification, which is in this area here, and the primary center of ossification underneath here. And then this part here in between is referred to as the growth plate. So if you were to look at that in more detail, in this picture you can see that it is rather organized so that the growth happens in an organized way. So within this you have a zone which is referred to as zone of reserve cartilage. That is where cells are resting and waiting a signal for them to proliferate, and they end up in this proliferative zone or zone of proliferation, and this easily identified by these multiple cells adjacent to each other in forming columns. The cells eventually start to become bigger and start to die off in this zone of hypertrophy, and that eventually lead to a zone of calcified cartilage. And then as the blood vessels are invading from underneath, those areas getting resorbed, and then the new bone is being formed around here. So this very organized way of cells being in reserve to cells eventually dying off and then cartilage turning into bone, the whole process is allowing the bone to grow in a longitudinal way. So this is a histological view of what you just saw, and again you can see this resting area here, proliferative area here, and you can see this stacking up of chondrocytes in nicely arranged columns, and then hypertrophy here, calcified matrix here, and then eventually resorption and formation of cartilage into bone, or true endochondral bone formation. And you can see this further in this picture here. Again, the bone is forming here. You can even see the osteocytes embedding themselves, with osteoblast forming the new bone here. C in this case referred to cartilage. So before we leave this section here, just to cover ourselves and say how bone heals itself. As I mentioned before, bone has a very high potential for healing, and it happens again in very organized stages. So when bone fractures in early stages, there's loss of damage to the blood vessels, and the hematoma forms in this area where the fracture is. And with that, there's a lot of cellular activity which brings in cells of the inflammatory phase, and there's a lot of fibroblastic cells that come in. So as the cells come in, they start to make the fibrous tissue in this area here, and then eventually that gets converted into soft callus, represented here in cartilage in blue here, and then also ossification starts as represented here in green. So the whole process is very active. There's a new bone being formed, the bone's being remodeled, and then the callus forming for stabilization, as well as allowing repair to take place. And then eventually the whole soft and hard callus becomes remodeled, and bone is end-to-end is healed, although not shown right here. So these pictures underneath are representing individual histological section of these phases. We don't expect you to really understand this in great detail, just accept the fact that the repair is happening in these well-defined phases.